All right, guys, in today's video, what we've got is we've got this drive shaft off a 3/4 ton old body style truck, and the end caps had rusted into the yoke, and we had to hammer them out. Because we had to hammer them out to get them loose, we damaged these caps. So even though this was a 23-year-old U-joint, it was still okay. We're going to have to replace it because we had to damage it to get it out. And that's fine. So first step in that is, we've got these two clips that are held in here and here. And the first step of getting this going is, since the other one was so badly corroded, I'm sure this one is going to be of the same nature. So we're going to let this soak for a little bit to try and give us a hand here. On both sides before we come off and try to pull these rings out of here. This is just really a clip or a ring. And it's a very old design. It's been around ever since the mid-1950s on these trucks. All right, so we'll let that sit and come back. Let me show you the other side. All right, the other side with the slip yoke is the same deal, except it has the ring on all four ends of the U-joint. And so if you were replacing that, you'd end up doing the same process I'm showing on this other end. So even though this one is just as old as the first one, there's nothing wrong with it. It's got no play in it. And we just want to kind of get in and out with this repair, so we're only going to swap the one out on the other side. If for some reason you wanted to do both, it's just going to be the same process 4 more additional times. So we'll let that soak, we'll pull the rings, and I'll show you how to push it out and push a new one in. All right, guys, we've let this sit soaking for about an hour or so while we did some other things. Let's see if it's going to be hard or not. And it is going to be hard. So that's super corroded on there. We're going to have to chip it out. Make sure you wear eye protection. So the general technique we're going to have to do when it's corroded in like this is we're just going to have to peel it off the groove painstakingly like this. I'm not going to show you both sides, but we'll work through this one. So there's another piece that broke off. So now we've got this piece here with 2 ends broke off. It's still possible to work it out. What we're going to have to do is get a weak spot and get back under it again. You just got to keep working both sides until you can get into one of them. It just takes a while, guys. It takes a long while, and you got to be patient. At some point, we'll get this guy to move one side or the other. Just kind of slowly keep working it out. Don't be afraid to use the penetrating oil to help break up this corrosion. All we're trying to do now is just let some of that oil work in there. All right, so this guy broke. Just have a variety of tools you can improvise with. All right, so that one's out. Just trying to give it a little shock. Let's go back to the other side. Now that we got that one off, we might have some more luck getting this to move a little bit so that we can finish this broken piece off here. All right, guys, this is on there really, really badly corroded. So a technique I like to do with problems like this is just to put something on with some tension and let it sit overnight in a position where it's soaking in oil. And we're going to check it out this morning and see if it's any better. You know, this is when you don't have a rush. Slow and steady with a lot of patience is often the best approach. So let's see if we got this guy to give up any. Make sure you use some hearing protection. All right. So we look on the other side. It looks like it might have moved a little bit. I don't know if it's enough to get anything out, but let's get a tool and see if that's the case. All right, guys, we're going to lube this up some more. I think we'll be able to get this piece of broken ring out now. Just like last time, we're just going to use some scrap screwdrivers and some eye protection to try and work this out. So we got this ring moving finally. We should be able to extract it. Just going to work it back and forth, try to get some of the lubricant to get in there. But yeah, this rust can be a pisser. I think that got it right there. Now I got another little broken screwdriver over here that we can use maybe to work it the rest of the way out. So I got to cover your view, guys. Just don't want this thing to go flying. There we go. All right. That gives us back all of the rings. All right. So we got the one off the other side, and we got this one. And I got another piece laying over here somewhere, so we got all that out. Now I'm not going to try to push this out with that ball joint press. I just like to use that to get the broken clip out. I mean, it obviously did move, and we probably could continue to push it through here using that, but my concern about using tools like that is whether we're going to get any damage to the ears. It's very important that even a few thousandths of an inch of this bending will then cause all the subsequent U-joints to wear out prematurely. And we got 23, 24 years out of this one. We want to get the same out of the replacement. So I'm going to show you a tool that is proper for this now that we've got these clips off, which actually just pushes on the U-joint itself, and we'll be able to put it in the press and just press it out that way. All right, guys, so what we're going to do here is we're going to set a socket on top of the press, and we're going to be using a 1 1/4 size socket, and we're using that because we want something that's big enough for one of these 3/4 ton size U-joint cups to drop right inside where this stays flush with the bottom. And then what we're going to be coming in with the drive shaft is when we come down, just going to lay it into view here on the camera. Kind of pull this out a second. What we're going to be using here is something called a spider press. And that's going to sit down on top of the U-joint and allow us to put all of the pressure from the press on this tool, which will then transfer it to the U-joint itself. And the pressure on the ear will be borne by the socket sitting underneath, so there's no possibility of you damaging the drive shaft with this technique. Right? So there's nothing wrong with using a ball joint press to pop these out unless they're really corroded, like this one turned out to be. And when they're really corroded, that's just way too much stress. So we're going to go with this technique. So we want to kind of clean up the edges so that our spider press doesn't have a chance of sliding off. And then I'm going to need to lower the shelf on this press a notch so that we can fit all of this in there, and we'll get started. Okay, once we have everything centered, we should just be able to push this guy straight through. Make sure you're wearing eye protection.
That's probably what you should wear too.
And you're going to push that down until the center of the joint bottoms out. All right, so we can see right there that it's kind of bottomed out. And once it bottoms out, we don't want to push on it too much more because, again, we're going to be resulting in damaging the ear. So if I pull this guy out, you can see we've extruded him partially, and we can see that we're right up against the ear now. So at this point, what we're going to want to try and do is work this guy out with a pair of vice grips or putting it in a vise and wiggling it out, because we might have enough room where we can do that now. All right, guys, this is on tight, 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 and cannot get this to release either in the vise or even with vice grips. So, you know, we're not too far away here, right? If we take a look at the other one, it's just about that much left on the thickest part. Now, what you normally would do on like a half-ton truck, we'd pull this piece back, we'd prise up the seal like this, and that tool that I'm using has an insert that would go in here, right? So this is a J95 22-5. But on these 3/4 ton type U-joints, it's too small, and they don't make one for this. And the problem is, if we take a look at the back, and we see this round type of stock joint, right? It's already bottomed out on the high point of the ear, so we can't push any more to get this out. So I think what we're going to have to do, I haven't done one of these 3/4 ton ones, so you guys are learning along with me. Just judging by the size of this guy and looking how far we've got it, I think the way to do this is we're going to take this back to the press, we're going to flip it over, we're going to put the spider press back on the top, and we're going to get this side to the same place we have that side. And I think with that kind of clearance, we'll actually be able to get the joint out, and then we can bash what's left of these caps out with a brass drift or something. Let's give that a shot. All right, guys, we've got it flipped around now. Going to reposition everything. Put our spider press back in and push this side down. Right, that was a loud let go. Let's just check it first. Yep, okay, she's coming through. Okay. Now let's see where we got to. All right, there you go. That was the trick. We needed to push it out on the other side. They still got this one on this side that's stuck. So we'll get a brass drift on him, and we'll pop him out, and then we'll be ready to install the new one. So guys, if we take a look at our old U-joint, we can see that even though we replaced this because we damaged it removing it, if we zoom in here, we can see the needle bearings were scoring the trunnion, so it was on its way out at some point. It's got about 300,000 miles on it and about 24 years of use. So you can definitely see some wear, right? So even when they don't shake around and they don't make any noise, it doesn't mean that it's not a good idea to replace them when you go do a job like this. The other thing I thought was interesting is we can still see some grease packed in here and packed in here. but not in here. And if we take a look at this guy, we can also see some corrosion or possibly some scoring. It's hard to tell. It's definitely rough to the touch as a result of that particular end cap not getting sufficient lubrication. All right, so let's take a look at what we're replacing it with. 890-59111. And what you get inside the box either way, this is an older one, so somebody certainly has probably opened it before. But what you should find in the box, along with this anti-corrosion paper, is a little package of 4 more retaining clips. And you just want to check these guys out and make sure that they don't have any corrosion on them. These here are made by Spicer for GM. And you also want to check and make sure that these cups are the same diameter as the ones you took off. Now, for some reason, you might get a deal. I've seen deals on these parts sometimes on eBay, like this one here. And on this one here, part of the deal was this is normally like a $70, $80 part, but got it for only 20 bucks because it's missing the clips. It's still a Spicer U-joint. It's missing the clips, and it's got some discoloration on the cups, which is not a problem. It turns out the two that have the discoloration we'll just put under the straps rather than putting them inside the ears, and we'll be fine with that. And we can get our own clips separately as part number 372-1973. And so 372-1973 are just the individual clips. In fact, these have been around for a very long time. I'll show you something else that's a cute fun fact about these, and then we'll get this thing mounted up. All right, guys, fun fact about this part, right? So 372-1973, Chevrolet group number 5.586. If I take a look at one of my old parts books, this is a parts book from 1957. I pull up group 5.586, and I go down and find this part number, 372-1973. I can see that these lock rings have been used all the way back since 1939 on 3/4 and 1-ton Chevrolet trucks. So talk about some heritage. It's well over half a century of use. All right, guys, the next thing we're going to have to do is we're going to have to chamfer off any burrs from pushing this cross into the ears. So right at the back here, we've got a couple of little burrs here we want to get burned off before we try to push the new one in. We're also going to want to clean out the bore here and get rid of any corrosion, get a nice shiny metal surface again. Next thing, guys, we're going to do is clean these bores out. We're going to start with some steel wool. We're going to go around until we can get to a nice shiny finish on both of these. After we've already got the edges nice and chamfered, that'll also prevent us from having the steel wool get cut up and torn while we do this. So we're going to do both the top ear and the bottom ear in this view is the next thing that we're going to chase. And then we're going to work our way up to a brass brush. We'll go around the ring grooves one more time to make sure that we don't have any embedded rust pieces all along the entire circumference of both seating areas where these rings are going to lock in here after we push the cups back in again. If you have areas of damage or particularly heavy scaling corrosion, then what I like to do is take a cutoff wheel on a Dremel tool and rotate it around in there. We'll start off doing it by hand first, and then I'll actually hook it up to the Dremel if I have that problem. This one's fine. The other thing you can do is if you have any impacts that have slightly dented anything around here, I'll show you on the other side where we had some of those. Then we can also use the Dremel to smooth those out. Now we actually do that before we tried to push the cups through because we don't want them to have any interference, but I can show you what that looks like. We're using a bungee cable to keep this drive shaft secure while we work on it. But here's an example on the other side where we had an impact right there. Right there when we were trying to get this out initially and get that corrosion seal broke. And what we ended up doing with that is, whoops, sorry about that, hit the camera a little bit, guys. So we ended up doing on that with the Dremel tool before we pushed it through the other end is we just came in here with this grinding disc and we just burred that off to make sure it was nice and round. We used one of the other caps as a gauge to make sure we had it right. There's another small nick over on this side, same thing. Just zipped it right off really quick, keeping the thing perfectly round, good circumference. Similarly, if you end up with something like that, now this side it wasn't really a problem, but again, you can come in here with the cutoff wheel and you can use that to reestablish the correct gap. I'm going to test that these fit the new rings before we push anything in, just to make sure. You should be able to put the ring in there and spin it around. I'll show you that. Just take a spare ring that you have of the same part number and type that you're going to be using. Get it mounted inside, and then what you want to make sure is that you can rotate it all the way around any areas that you thought might have been damaged, and make sure that it's not binding, it's not getting stuck on anything. That's going to let you know that everything is nice and in specification. Now it shouldn't be loose, it should be super tight. So you should have to be able to turn this with a pair of pliers, right? If you're able to turn this with your fingers, you've got a problem. But nope, we're in good shape here. We'll go test the other side, and we're ready to push the new U-joint back in. When you look on the inside of these GM U-joints, there should be a little instruction flap in here. And it's a big caution symbol. And it tells you that this kit contains only enough grease to provide protection during storage. It's necessary to completely lubricate each kit prior to installation to prevent premature failure. Each journal cross lube reservoir should be fully packed with the recommended grease. Each bearing assembly should be wiped with grease, filling all the cavities between the rollers and applying a liberal coating on the bottom of each race. Right, so what we're going to have to do here, because these don't have a Zerk fitting, is we're going to have to manually load that grease up into each cap before we install it. So I'll show you that while we put it on. All right, guys, the first thing we're going to do here is put a little lubricant on here. This will help clean up any bits of steel wool that might have gotten around here. We also blew some compressed air on there, but we want to get that all cleaned up and ready to receive the new cups. Next thing we're going to do is I'm going to take a look at the old and the new. And we're going to make sure that we've got about the same size. So this is 30.26 to 4 millimeters, and the other one is 30.29. Just making sure we're grabbing it right in the middle there. 2.3, 2.4. All right, so yep, we're trying to make sure they're both the same. When we take a look at it side by side, we can tell these are two different suppliers from GM, because if we pull this guy off here, we can see that the seal is kind of coming off on that side, so it tricks your eyes, but you can see it sticks down just a little bit longer than the new one. Now there's no markings on the old one that I can make out, and it's definitely not the same type of Spicer rear end. I don't know, it might be an American Axle and Manufacturing supplier or somebody else. You can see it's a little bit smaller in the center, but this is the correct part number from GM for the VIN on this particular vehicle. So we're also going to take our PB Blaster soaked rag, and we're going to make sure we don't have anything on the new one. We're looking for any kind of grit or anything like that. And then the next thing we're going to have to do is, you saw when we read the instructions, these type of factory joints do not have a Zerk fitting. They're permanently lubed for the life of the part. And they come shipped with some pushed in here and some pushed in there, but like you saw in the information on the box, you need to put in more. So the way we're going to do that is I'm just going to set it over here on this little bench area, and we're just going to put some GM chassis grease in here. Put a little bit in there, and then we're going to push it into the bore just to make sure that that's fully loaded up. And we're going to do that to all four before we install it. All right, guys, when you go to take a look at the lock rings, they measure in at about 1.5 to 1.53 millimeters. All right, just like with a Zerk fitting type, you want to make sure that when you push it on here, it's well situated on all the needle bearings, and then you'll just get a thin film coming out as you give it a squeeze, and then you can take that excess and remove it, and that's how you know you've got enough in there, and now they're ready to push in. All right, guys, it's time to put it in. So I'm going to tape off the two that we're not working with. We're going to grab the first of the one that we are working with. Just going to get him started. Take the other one off. Slide this guy in. Slide this guy in. And what we've got to be careful of is that none of those needle bearings got messed up. Just going to use a plastic hammer to get it started. We're just making sure everything's moving around nice and good. All right, so now we can put our ball joint press back in here. We've put this in as far as we can with the plastic hammer. We're just going to use a couple of little bushing adapters on this side. You could also use a socket, just something to line up with that will catch the base of the C piece while you turn this end in. Since we're not fighting the rust now, this should go pretty easy. In fact, we're just going to turn it by hand for a moment just to see how far it goes. This guy's going in, just turning it. You know, if you slide the camera over here, I'm just turning this by hand. Don't even have a wrench. And you can see she's going in that easy. So let me go ahead and grab the wrench because we're going to need that to seat it on both sides. All right, so what we're going to do is we're going to get this side in until we can install our locking clip. As soon as we see that we can do that, we're going to back it off. Take one of our clips. It looks like, whoops, looks like it might be ready, but might need to go on just a hair more. We'll see. These particular pliers are just not cooperating with me. All right. So we are probably just a hair off. We can seat it with that plastic hammer. There we go. Yep. So our ring is in the groove where we want it. Now let's go do the other side. All right, now that we got this one in, we're going to go back to using something larger because we don't want to press on this one anymore, and we'll go ahead, flip it over, and seat this one. All right, now let's do the other side. You know, we're just going to keep checking, make sure everything's not binding. And the same deal, we're going to take it down right until we can see where the lock ring is going to snap in. All right, that looks like it. It's going to go down just a little bit more. And then we'll take this off. And we'll see if it's enough to put the last ring in or not. I don't think so. I don't think we can plastic hammer it down enough. We'll have to maybe give it another turn. We'll try this. Now you guys can see it's just a little bit more before we can put the ring in. Won't take much. Let's see if we got it that time. And if we didn't, won't necessarily drag you guys on with this trial and error. I just like to be very conservative with this stuff. We'll give it a shot and see if it's enough. So guys, another thing to point out too is you want to pay attention to whether these clips are really seated or not, right? You look at the space between this curve and the long angle piece, right? It should be further over. So we flip it onto the one we did first. Right, we can see that this is near the end, and that's a good indication for us that is all the way in the groove. But this other one over here is not. So it tells us that we've got a little bit more to go before this one's done. So even though when we pull this out of here, it looks like the groove's clearly visible, it's obviously just another hair more that we're going to have to push it in before this is going to seat properly. And we absolutely want to make sure that this does seat properly because this is a safety device to keep this from coming out. Right, so it goes down almost all the way, but we're just a hair off, right? So that's something you want to watch out for too, because this looks like it's in. And it's partially in, but it's not all the way in, right? So watch out for that too. All right, guys, we're here at the end. We got everything in position. What I'd recommend you end up doing after you get everything where you want it, you can give it a shot on the edges with some fluid film just to keep the surface rust off for the first 500 miles or so while you watch how things are panning out to make sure everything's good. Let's talk a little bit about tension, right? So after you got this in here, you should be able to move this with just 2 fingers, right? It's not going to be loosey-goosey like one that's worn for 20 years, but you shouldn't have problems moving it with just even your thumb. It's going to be stiff, but there should be no binding. You shouldn't feel any vibrations, and you shouldn't feel any kind of, like a roughness in there. Anything like that means you should take it apart because something went wrong. Maybe a needle bearing got underneath between the trunnion and the cap, or any number of things like that, or a piece of debris got in there, grit or something. It should be super smooth and super firm, but not where you can't move it. If you're having to like tap on this with a hammer or having to grab the whole thing, it's bound up. Now, if it's bound up, what you can sometimes do is you can grab a brass hammer and a brass drift and give it some shock taps with it under tension with the springs. Sometimes it'll move a little bit, and that's enough to free up something like that. This one doesn't need it, but I'll just show you the technique. Just right around the thick part. You can use the brass hammer itself if you want, but you got to be careful you don't hit anything like this. So you're not going to be hitting it really hard. It's not like what you would do to try and get it apart. You're just trying to create a shock that when this is all under tension, it'll move a little bit. And sometimes if you've got a binding situation, that can be enough to free things up. The reason for brass is the brass is softer than the steel, so it won't cause any dents, it won't do any damage. If you do happen to hit and miss, it's very unlikely to damage the caps because the brass is softer. What tends to happen is the brass itself takes the hits, and it ends up getting all scorned and dented, but the steel is left unchanged. We use a brass drift just so that we can have more control and don't hit anything. Anyway, we are done, guys. This is ready to reinstall back onto the vehicle. If you have any questions or comments, go ahead and leave them below. I'll try to help out. If this helped you or it saved you some time or money or you learned something, again, check the description for links to the parts and some of the tools I used. And if you got those questions, I'll try to help out. Otherwise, as always, thanks for watching.